Hello. In this lecture, we will discuss about the production of the electromagnetic waves. In the year 1865, Maxwell theoretically predicted that the existence of the electromagnetic waves. However, it was in the year 1888 that Hertz experimentally confirmed the existence of electromagnetic waves. The Hertz experimental setup consists of two metallic plates made up of copper or zinc, held parallel to each other and separated by nearly 60 centimeters. The two plates are connected to the metal spheres S1 and S2 through the metal rods R1 and R2. These are the metal rods, these are the spheres S1 and S2. The gap between the S1 and S2 is about 2 to 3 centimeter, and this gap can be adjusted by sliding the spheres over the rods. An induction coil, which is the source of the high voltage, is used to produce a potential difference of several thousand volts between these metal plates. Due to the high voltage, the air in the small gap of the sphere is ionized, and it provides the path for the discharge of the plates. The spark begins to pass between the spheres, and very high frequency of the order of 10 to the power 7 Hz oscillations of charge occur. It results in the high frequency oscillating electric fields in the gap S1 and S2. Consequently, an oscillating magnetic field of same frequency is set. These oscillating electric and the magnetic fields constitute electromagnetic waves. The frequency of EM wave is the same as the frequency of varying electric and magnetic fields. The EM waves so produced are radiated from the spark gap. With the help of this setup, Hertz was able to produce the EM waves of about 6 meter wavelength. Now here is a detector. This one is a detector which consists of two spheres S1 and S2 dash connected by a wire. It makes another inductor capacitor combinations. The frequency of the detector is made equal to the frequency of the EM waves radiated from the spark. The detector is placed in a position in such that the magnetic field produced by the current is perpendicular to the plane of the coil. The resultant electric field induced by oscillating magnetic field causes the ionization of the air in the gap between S1 dash and S2 dash. So a conducting path becomes available for the induced current to flow across the gap. As a result, a spark appears in a narrow gap. And this spark was more intense when S1, S2 and S1, S2 dash are parallel to each other. And it is a clear evidence of the polarization of EM waves. Now, next topic is electromagnetic spectrum. As you know about the visible spectrum or the light spectrum, in the light spectrum, the 7 colors of the light are arranged in the order of their increasing wavelength, or you can say in the order of increasing frequencies. And you know that order is violet, indigo, blue, green, yellow, orange, red. In the same way, there are the 7 electromagnetic radiations, that is the gamma rays, X-rays, ultraviolet, visible, infrared, microwaves, radio waves, and these 7 rays are arranged in the order of either increasing wavelength or decreasing frequencies, and is called electromagnetic spectrum. Now let us discuss each wave one by one. The first wave of the electromagnetic spectrum is a radio. The range of the wavelength of the radio wave is from the few kilometer to 0.3 meter. The frequency of the radio wave is from few hertz to 10 to the power 9 hertz. Radio waves are produced by the electronic circuits which produces the oscillations. These oscillating circuits consist of the inductor and capacitors, and which produces the LC oscillations. These radio waves are used in the radio and the TV communication. These are also used in cellular phones. The next wave which we have to discuss is a microwave. The microwave has a wavelength from 0.3 meter to 10 to the power minus 3 meter. The frequency range of the microwave is from 10 to the power 9 hertz to 3 into 10 to the power 11 hertz. These are also produced by using the LC circuits, and you have seen it in the microwave cookings. That is, magnetron is used to produce the microwave. It is used in radar, microwave oven, to analyze the fine details of the atomic and the molecular structure. Thank you and have a nice day.